we want to move to the sixth theorem of the circle geometry. And don't forget, the first theorem we discussed was when you have a radius, like a radius, to meet a chord. If it's meeting a chord at the perpendicular line, definitely it is that perpendicular line is as well a perpendicular bisector of the chord. That means it's cutting that chord into two equal halves. That was the first theorem. And the second theorem discussed the angle at the center being twice angle at the circumference. And our third theorem discussed angle in the same segment that are equal. Then the fourth theorem talked about angle in a semicircle. Anytime you have a diameter in a circle, there is a 90 degree there. They said angle in a semicircle is a right angle. That means it's 90 degree. We discussed that too. And after that, we discussed cyclic quadrilateral. I said if you have a quadrilateral inside the circle, it's called a cyclic quadrilateral. And that circle, that quadrilateral must have its vertices at the circumference of the circle. That means the four vertices of that quadrilateral must have themselves or their points at the circumference of the circle, not having one. If you have one at the center or somewhere else and others at the circumference, no, the four must be at the circumference. So the opposite angles are supplementary. That means they both add up to 180 degrees. So after we did series of exercises to help our work, and today we need to move again. Some textbook will call this one circle geometry 2. And I know the reason why they start to talk about, because this one, every geometry here, every theorem here, sorry, are discussing tangent. They are particular on tangent. So what is a tangent? We need to know what a tangent is before we proceed. Please, pardon me. Tangents, it's a line that touch the circle, That means at the circumference, if a line, a straight line, touches the circle, this line is called tangent. So this is tangent TA. It is not a secant. It is not a chord. A secant is different from a chord and is as well different from a tangent. This is a secant. Please, this secant is not even a chord though, because this one, if this is A and this one is B, this line is the secant, unlike this line that only ends here. So a chord is a line that runs from a circumference of the circle to another circumference of the same circle. But a secant crosses. Can you see? It just passes through. It passes through that center. It's actually not a basic thing. It's just passing through the center. It's passing through the circle. So this is a secant. Secant. And this is a chord. This is a chord. Please note that. And this is a tangent. I'm not talking about tangent in trigonometry. It's just English here. This is a tangent. So how does this one relate to this? Now listen. If you have a radius that is drawn to meet a point of tangency, this is a point of tangency, like the point of tangency. This is a point of tangency of a circle. Is perpendicular. It is perpendicular to that tangent. Any radius that you draw to meet the point of tangency, you must have a 90 degree there, compulsory. Please note that. Anytime you draw a radius from the center of your circle to meet a tangent at the point of tangency, this is a tangent line of tangent. So we can, if you can cross this way, you can go this way. This is not 90 degree because it is not the point of tangent. This is the point of tangency where the tangent meets the circle. It is a point of tangent, that is T. So that is a point of tangent. I labeled it T. I can label it anything though, but I labeled it T. So once we have this one to this point, there must be 90 degrees, and obviously there will be 90 degrees. So this line is a perpendicular line. Don't forget what a perpendicular line is. Is a line. There are two lines that meet at 90 degrees. So this radius is perpendicular to this tangent. That is the first theorem. Let's check the seventh theorem directly. To theorem 7 now. Before we do classwork on the theorem 6 and 7, let's This theorem 7 is the only 3-in-1 theorem. This is having 3 theorems in one. I call it 3-in-1 to my students. So when I say theorem 3-in-1, they understand what I'm trying to say. So here, let's see. If two tangents, now we discussed one tangent the other time on theorem 6 with the radius. So it's the radius and tangent relationship. But this one is going to be tangent and tangent relationship. Of course, it's going to be having is effect with the radius, but we need to separate it. So we have two tangents now. So if two tangents are drawn to a circle from a given point outside the circle, if two tangents are drawn to a circle from a given point outside the circle, then the tangents are equal in length. The tangent subtends the same angles at the center of the circle. The angle between the tangents is bisected by the line joining the center of the external point P. So external point P, let's call this one P now. This leaf story, nobody's going to ask you what this is going to be. They are not going to tell you what state theorem this, state theorem that. No. Just it's the application that matters now. What this one is saying, let me explain. If you have two tangents, tangent 1 and tangent 2, look at the points of tangent C, tangent 1 and 2 drawn to a center from the given point outside the circle that they meet. If they meet outside the circle, so definitely the tangents are equal in length. That means if they should meet, this length is the same thing as this length. Please note that. Then the tangent subtends the same angle at the center of the circle. That means the tangent subtends the same angle at the center of the circle. So this angle is equal to this angle. Please note that. And the angle between the tangent is bisected by the line joining the center of the external angle. So this one, it means this angle is equal to this angle. Now, even me, I know, because it looks like it's like a congruency now, because this is 90 degrees and this is 90 degrees. So if this is 90 degrees and this is 90 degrees, that is theorem 6. These are radii. So if these ones are radii, definitely by RHS, that is congruency. That means RHS, you have what type of congruency? We call it side, that is SSS. And we have side included angle side, that is SAS. Then we have angle side angle, that is angle corresponding side and angle, that means ASA. I call it ASA, I call that one SAS. Then the fourth one is RHS. So this is by RHS, this one is equal to this. This side is equal to this side. This side is equal to this side. Definitely this angle will be equal to this angle. Why this angle will be equal to this angle? That is just automatic. That is what the theorem is saying. So this one is not stressful. It doesn't take much time to comprehend. Let me take it again. If you have two tangents, that is, you have two tangents, tangent this and then if you have two tangents, this is this, tangent this and tangent this, meeting at a point, they meet. So once they should meet, then you should just relate the radius, the radii together, then equate this one to be equal to this, equate this one to be equal to, because automatically this one will be equal to this, and we know the radii, this one is equal to this. That is the theorem. Let's check through example. Example now. Pay attention. We have lines of tangents 2, and we have radii. Look at this now. I don't forget, what do you have here when you're working? Your pencil. Please pick your pencil. Let's work first. Assuming we are doing JAMB examination, all you need to do is to relate it. Once you relate it, then you pick your answer direct. But we are going to solve this as WAEC alongside with JAMB, having our pencil. So from here, we will solve our work. We understand it before we analyze it for mark. So knowing is different from solving. So we'll know and as well solve, so that you will now decide which one you are going to do, if it's WAEC or JAMB, as the case may be. So let's look at this. Theorem 6 is telling us that if this radius meets this tangent, there is a 90 degree here, and definitely there will be 90 degree here. That one is solved. And theorem 7 is saying that because these tangents meet here, definitely if we cut a line into if you have a line like this angle is equal to this angle, so this angle is equal to this angle, definitely we are going to divide 54 by 2, that is 27. So this one will be 27 and 27. I don't know if you are going to use it, but still the question asks us to find TAB. That means TAB means we need to send A to B now. That is, so we are looking for this angle. Wow, wow, that is interesting. I call this one X, then OAB, OAB. So this another angle. Wow, wow. We are solving for these two. Then ACB, ACB. That means this angle. That is Z. Huh? Interesting. I'm sure this is going to be interesting. Let me repeat this. We were asked to find TAB. That means this angle. It is not angle OAT. It is not the entire angle here. The OAT is obviously 90 degrees. So, and addition of y and x gives you 90 degrees, as you can see. So we are looking for y. How do I get y? Look at this. This one is 54. This one is if this one is 54 and you are sure this side is equal to this side, definitely this angle is equal to this angle. So if you take 64 from 180 and you divide it by 2, you have this and this. So you have your x. And to get your y, you take this one from 90 degrees, you get this one, your y. So to get this angle, angle at the center is twice angle at the circumference. So whatever thing we get here, we divide it by 2 to get our head, our z. That's all. So let's see how it goes. From here we have 50, that is 180 minus 54. We have 54, sorry. This is 10, that we have 6. This one is 126. So once we have 126 here, we divide it by 2. That is 63. So this one is 63. This one is 63. So we have 63 here. So this one, y will be 90 from 63. That will be 17 or so. 27. Sorry. That will be 27. So once we have 27 there, then to get that's our y, that is the second one is 27, this is 63. So to get this one, we'll need this one. So this one is 90 and 90, and this minus 360 will give us this. So once we have that is trigonometric and quadrilateral, then whatever thing we have here, we divide it by 2 to get our angle. So let's work. So far we have how do we get this one now? Don't forget we have this one. So far we have TB to be equal to TA. Therefore, these ones are base angle of an isosceles triangle. So we have isosceles now. Therefore, we have let's call this one A and A. So we have A plus A is equal to 50 plus 54 degrees is equal to 180. That is triangle. That is, you don't have to write A now. We can have TBA plus TAB will give you this. So this one is the same thing. So we have 2 of A is equal to 180 minus 54. So we have 2A to be 126, and our A is equal to 63 degrees. So if this A is equal to 63 degrees, we have 63 degrees. So to get our Y, that is OAB. So OAB now will be equal to 90 minus 63. That is 90 minus 63. That will be 27 degrees. Why is this one? We have complementary. We can have complementary angle. That is 90 degrees. So combination of y plus x will give you 90 degrees. So that's complementary angle. So to get this one, we need, like I said, we need this part. So we join 90 here plus 90 here plus 54 here plus this angle AOB to give us 360 degrees. That is quadrilateral. That is 54 plus 90 plus 90 plus BOA, that is plus BOA is equal to 360. That is quadrilateral. So we have 90 plus 90, that is 180. 180 plus 54 plus BOA angle is equal to 360 degrees. So we have 4, we have 13, then we have 2 plus BOA is equal to 360 degrees. So from here we have BOA, that is 360 minus 234. So we have 6, this one remains 5. 3 from 5 we have 2, and we have a 1 here, that is 126. That means this combination of this. So if this one is 126 degrees, then our Z, that means, is equal to ACB will be equal to 126 divided by 2. That is, angle at the center is equal to 2x, twice angle at the circumference. So we have 63 degrees. So ACB is equal to 63 degrees. That's all. That's all we have there. This is, but don't forget, if it is jam, we have already gotten our answer. We have gotten this, we have gotten this, we have gotten this. But we need to write it out so that we can have a mark from our head. So that is all.